Okay, so let's unpack this. I think pretty much everyone at some point has had that specific dream. You know, the one you're scrolling online, maybe late at night, and you stop on a photo.
Mm-hmm. The one in the wide open field.
Exactly. The lighting's always perfect, and there's this massive open concept building. Maybe it's a high-end workshop for that classic car you've been meaning to restore,
A horse barn.
a horse barn, or maybe it's that trend that is just it's taking over my social media feed, the barndominium.
It's a really compelling image.
Yeah.
It's about more than just a building. It's
Huh.
it's about autonomy,
Yeah.
creating a space that's entirely yours.
Right. But this is where the dream usually hits a wall. You start thinking about the uh the actual execution, the math.
And traditionally, that means wood framing.
It's the default, yeah.
Yep.
But then you start hearing the horror stories. Lumber prices going crazy, trying to find a good framing crew. And then there's that nagging fear of, well, of nature.
Because nature, eventually, it always wins.
That is the core tension we're digging into today. It's this clash between the romantic, traditional idea of building with wood and the, let's call it, industrial efficiency of modern steel.
Mm-hmm.
We've got a bunch of technical data and comparisons here from Steel Commander Corp, and since they manufacture prefabricated steel buildings, they have a very engineering-focused take on this.
And their data is pretty revealing. It really challenges a lot of our assumptions about what permanence even means.
So our mission for this deep dive is simple. We're going to look past the drywall, past the paint. We're getting to the bones of a building.
The skeleton.
Exactly. And by the end, you'll understand the real technical and financial reasons why builders are shifting to steel. And this is the part I'm excited for. You'll finally know the difference between a C-channel and an I-beam.
Which is way more important than you'd think. It really determines what the building can even do.
I believe it. But let's start at the beginning. The whole problem with organic materials. I mean, I grew up thinking wood was the gold standard. It's sturdy, it's natural.
The fundamental problem, really, is that trees are made by nature, not by a factory.
Okay, fair enough. Nature doesn't really use a measuring tape.
Not at all. And when you're building something you want to last for, say, 50 or 100 years, consistency is everything. With wood, even if you cut every single board to the exact same size, you're still dealing with all these biological differences. Grain density, knots, internal tension. It's different from tree to tree.
So, wait, two studs right next to each other in a wall? They could look identical, but they're actually behaving differently.
Precisely. One might have a higher moisture content, another might have grown on a slope and have different compression strength. And all of that leads to what the source calls the aging factor.
Okay.
Wood doesn't just sit there. It interacts with the environment. It splits, it cracks, it warps.
There was a term in the notes that sounded like it was from a horror movie. The creep.
Yes, creep. It's an engineering term, but it definitely fits.
Mm-hmm.
Creep is the slow, permanent deformation of a material when it's under stress for a long time.
So, gravity, basically. Just
Yep.
gravity working on it for years and years.
Gravity, a heavy roof, snow load. Think about an old wooden bookshelf. You load it up with heavy books, and over time, that shelf starts to bow in the middle.
Right.
Even if you take the books off, the bow stays. That's creep.
And that's happening to the beams in your house.
That's happening to the structural beams. A perfectly straight roofline today might not be so straight in 20 years. It's a slow, relentless process.
That is a terrifying thought, a slow motion collapse.
And we haven't even mentioned the biological threats yet.
The things that literally eat your house.
Termites, mold, mildew. I mean, their job in the ecosystem is to break down organic matter. If your building is made of organic matter, you are in a constant fight against nature just doing its job.
So you're living inside a giant meal.
In a way, yeah. And then there's moisture. Wood is hygroscopic.
Hygroscopic.
It means it absorbs and releases water from the air. It expands when it's humid. It contracts when it's dry.
And that's why old floors creak?
That's exactly why. The wood is moving. That movement loosens nails. It cracks drywall. Steel, on the other hand, is inorganic. It doesn't care about humidity. It just stays put.
Which I imagine makes the construction process a lot different. The source mentions traditional builds are just more complicated.
It's about labor. A wood build requires so much on-site fabrication. You have a pile of lumber and a crew with saws measuring and cutting every piece. It's a craft, but it's slow.
Whereas the model from Steel Commander Corp is more like a kit.
Exactly. It's prefabricated. All the pieces are engineered, cut, and drilled in the factory. When it shows up, it's less like building and more like assembling a giant, heavy-duty model. You save a ton on labor costs.
Okay, that's the physical argument. Nature's chaotic, steel is uniform. Let's pivot to what usually makes the final call for people, the wallet.
The so what for your bank account.
Exactly, because you hear premium material and you just assume it's going to hurt financially forever. But the data here suggests it's more about the forever price.
The total cost of ownership, yeah.
Right. And there's a number here that just jumped off the page. The source claims steel buildings can have up to 50% reduced maintenance costs. 50%.
I know, it sounds incredibly high. But if you think about what we just discussed, it tracks. What do you spend money on to maintain a wood building over, say, 20 years?
Painting, sealing, pest control.
Replacing rotted boards,
Right.
fixing warped siding, dealing with mold. If you take away the organic material, you take away all those problems, you're not fighting decay anymore.
You're just washing it sometimes.
Pretty much. But there's another angle people forget about until closing. Insurance.
Yes. The source mentions a 25% savings on insurance. That's not small. Why do insurers love steel so much? Is it just fire
And
resistant?
higher is the big one, absolutely. Steel's non-combustible. A wood frame is fuel for a fire, a steel frame contains it. That massively lowers the risk of a total loss.
Okay.
But it's also about things like floods and high winds.
How is steel better in the wind?
Well, these engineered steel structures, they have much higher ratings for wind uplift and shear strength. And because they're bolted together, not nailed, the connections themselves are just physically stronger.
So in hurricane, the building is more likely to stay put because the roof is literally bolted to the walls, which are bolted to the foundation.
Correct. And for an insurer, that kind of predictability is gold. The source points out that insurance costs for traditional buildings are all over the place because the risks are so variable. With steel, the performance is engineered and certified. It's a known quantity.
Predictability saves money. I get that. Okay, this is where it gets really interesting for me. The nuts and bolts, literally. I never realized there were different kinds of skeletons inside these buildings.
This is the real aha moment for anyone planning to build something, understanding the structural systems.
So we have two main players, the C-channel and the rigid frame, also called the I-beam. Let's define those. What exactly is a C-channel?
Think of the C-channel as the efficient, economical choice. If you look at a cross-section of the steel, it literally looks like the letter C, a flat back with two lips.
Creative naming.
It works. These are usually made from a thinner gauge steel that's cold formed.
Cold formed. What's that?
It just means the steel is bent into its shape at room temperature, not heated up.
Yeah.
Think of it like folding a very, very strong piece of paper. The big advantage is simplicity. There's no welding needed to make the channel itself.
So it's lighter.
Lighter, easier to handle, and it requires less engineering time up front. The source calls it the simplest and most economical system.
And who's this for?
This is perfect for your backyard workshop, a detached garage, maybe smaller storage buildings, projects where you want the protection of steel, but you're not trying to span a huge area or support heavy equipment.
Got it. C-channel is the lightweight champ, but then you have the heavy hitter, the rigid frame, the I-beam.
The I-beam. Yeah, the source calls this one the perfect choice to last a lifetime. And physically, it's a completely different animal. This is what people often call red iron steel.
So why is the I shape so special? We see it everywhere. Skyscrapers, bridges. What makes that shape the king?
It's all about physics and putting the material where it does the most work. When a beam bends, the most stress is on the very top and the very bottom edges.
Okay, that makes sense.
The middle part of the beam, the vertical part, is really just connecting the top and bottom. So engineers figured, why waste a bunch of heavy, expensive steel in the middle where it's not doing as much?
So they just thinned it out.
Exactly. The I shape puts most of the material, they're called flanges, at the top and bottom, right where the stress is highest. The source calls this putting material along the axial fibers.
Axial fibers. Sounds very high-tech.
It's just a technical way of saying the lines where the force travels. By doing this, you get a beam that is incredibly resistant to bending and shear stress, but it uses way less material than a solid block would.
So it's not just that it's steel, it's that the actual shape is engineered to fight gravity.
Precisely. And that's what allows for clear spans.
Explain that.
A clear span is a huge, open interior space with no support columns in the middle. Because the I-beam is so strong, it can support a roof over a massive area. We're talking 60, 80, even 100 feet wide,
Right.
with no posts in the center.
So if I'm building that dream barndominium and I want that huge open living room with soaring ceilings, I'm probably using a rigid frame.
Almost certainly, yes.
Mm.
especially if you want that vast, uninterrupted space. It's also what's used for commercial warehouses, industrial buildings, anything that needs a lot of open floor.
I saw a detail about the columns being tapered.
Yes, so the vertical legs of the frame are often wider at the top where they meet the roof, and they get thinner toward the bottom.
Why do that?
Same exact principle. The most stress is at that corner, the haunch, where the wall meets the roof. So you put more steel there, you taper down toward the floor where there's less bending force. It's just incredibly efficient engineering.
Okay, structure is down, but we can't talk about modern building without talking about the environment. And when I think green building, I'm thinking bamboo floors, not a giant steel warehouse.
That's a common misconception. Steel is actually one of the most sustainable building materials there is.
How so?
It really comes down to the end of a building's life. What happens when you demolish a wood-framed house?
It goes to a landfill, I assume. It's full of nails and paint and chemicals.
Right, it's very difficult to recycle.
Yeah.
But steel, the source has this incredible stat. Steel is 98% recyclable.
98%. That's basically all of it.
It is. You can melt down an old I-beam and turn it into a new car or a new bridge or another I-beam. It never loses its properties. It's a closed-loop system. You're not consuming it. You're just borrowing it for a while.
That's powerful. The source also mentioned another efficiency angle, this factory direct model.
Right. They emphasize this a lot. In traditional construction, your materials pass through so many hands. The mill, the wholesaler, the lumber yard. Every step adds cost.
And they just cut out the middleman.
Factory direct. You buy the building kit from the same people who engineered and made it. They say this saves thousands of dollars, but it also speeds everything up. Less waiting for materials means less energy wasted on the job site.
And speed is a form of sustainability, for sure.
Absolutely.
Okay, let's talk about what these things actually look like. Because I think a lot of people hear steel building and they just picture a gray, soulless box.
But the versatility is amazing. We've talked about the barndominium, which combines that cool industrial look with a cozy home.
But the source lists agricultural barns, huge riding arenas, aircraft hangars.
And they don't have to look raw. The source mentions they come with a finished look, specifically a gray oxide primer shop coating.
And what does that do?
It protects the steel while it's being shipped and put up so it doesn't rust. It also gives you a clean, uniform base to start with. From there, you can cover it with whatever you want.
So you can put brick or stone or normal siding on it. The steel is just the skeleton. You could make it look like a classic farmhouse if you wanted.
Correct. And that skeleton is adaptable. They create custom engineering plans for your specific location.
Which connects back to that insurance point.
It does. If you're building in Florida, your kit is engineered for hurricane-force winds. If you're in Minnesota, it's engineered for heavy snow loads. You can dial in the safety margins so much more precisely than with wood.
It's like customized armor for your building.
That's a great way to put it, yeah. You're buying a structure that's mathematically proven to handle its environment.
So let's zoom out. We've gone from the microscopic creep in wood fibers to the physics of I-beams. It feels like the real argument here is about certainty.
It is. It's a move from the inconsistent to the consistent.
From organic materials that, I mean, they're beautiful, but they rot and warp and attract pests, to engineered, recycled materials designed specifically to resist stress.
And from a money standpoint, that upfront decision has this massive effect on the back end, saving 50% on maintenance and 25% on insurance. I mean, over 30 years, that's a college fund.
That really puts it in perspective.
Okay.
So while wood has all this history, the point here seems to be that steel offers permanence.
Permanence is the word. Wood is temporary. It's fighting a losing battle with the elements from day one. Steel just changes the whole timeline.
Which leads me to one last thought I want to leave everyone with. We tend to think of our homes as these temporary shelters, right?
Yeah.
We kind of accept that they're going to decay along with us.
We normalize it. The creaky floors, the drafty windows. We treat houses like they're disposable.
Exactly. But if you build with a material that is 98% recyclable and physically can't rot, are you just building a home? Or are you actually building a legacy asset?
Something that will outlive its original purpose.
Right. If that skeleton is still perfect in 100 years, that building isn't a throwaway item, it's an heirloom. It could be your workshop today, your kid's art studio tomorrow, and something totally different a century from now. And that kind of changes how you think about that backyard dream, doesn't it?
It really does. It stops being about building a shed and starts being about leaving a mark.
Thanks for diving deep with us today. Go check out some I-beams, look for the flanges, and we'll see you on the next one.